So this is problem 3 from practice exam 2 from exam 2. So this multiple choice question is asking, let G be a graph with 15 edges. If all vertices have degree of at most 3, what is the minimum number of vertices in the graph G? So right off the bat, this question is giving us like the number of edges, and it's asking a question about the number of vertices. We have a theorem that lets us to connect the degree of a vertex with the number of edges. It's the handshake theorem, so this is probably a good place to start with this problem. So first we can write out the handshake theorem. The handshake theorem says that if we have a graph and we add up the degree of all the nodes in the graph, that sum will be equal to 2 times the number of edges in the graph. So this problem says that there are 15 edges, so E equals 15. We multiply 15 by 2, we get 30. So from the handshake theorem, we can then say that the sum of all the degrees of each of all the nodes is equal to 30. So the next thing this problem says is that if all vertices have a degree of at most 3, what is the minimum number of vertices? So we can think of this like if we want to minimize the number of vertices, then we want to make sure that each vertex has the highest degree possible. This problem states that the highest degree that a vertex can have is 3. So assuming that each vertex has a degree of 3, we can then divide 30 by 3 and get 10. So 10 is the minimum number of vertices in the graph. And this would be assuming that all of the vertices have the highest degree possible, which is 3. So the answer for this problem is C10.